Hello and welcome you all. Friends, let us start with JEE Advanced 2018 Paper 2 Physics. Before going further, please press the subscribe button and don't forget to press the bell icon to receive the notification of all my future videos. Our first question is, a particle of mass m is initially at rest at the origin. It is subjected to a force and starts moving along the x-axis. The kinetic energy K changes with time as dk divided by dt equals gamma t, where gamma is a positive constant of appropriate dimensions. Which of the following statements is or are true? Statement A. The force applied on the particle is a constant. Statement B. The speed of the particle is proportional to time. Statement C. The distance of the particle from the origin increases linearly with time. And statement D. The force is conservative. It's a very interesting and challenging problem from work, power and energy, and have one or more than one statements correct. Let us now examine the question. Given the kinetic energy of the particle changes with time as dk by dt equals gamma t, where gamma is a constant. Using kinetic energy K equals half mv square, we get dk by dt equals mv into dv by dt, which equals gamma t, or v dv equals gamma by m into t dt. Integrating both sides, we get integral of v dv equals gamma divided by m into integral of t dt, or v square equals gamma by m into t square plus c. Since at t equals 0, v equals 0, we get c equals 0. Therefore, v square equals gamma by m into t square, or v equals root of gamma by m into t. Equation 1. This shows that statement B is correct. Differentiating statement 1 with respect to time, we get acceleration A equals dv by dt equals root of gamma divided by m, or force F equals m into A equals root of gamma into m equals constant. Therefore, statement A is also correct. Now, using equation 1, we get ds by dt equals root of gamma divided by m into t, or ds equals root of gamma by m into t dt. Integrating both sides, we get integral of ds equals root of gamma by m into integral of t dt, or s equals root of gamma by m into t square divided by 2 plus c dash, where c dash is the constant of integration. Since at t equals 0, the displacement s equals 0, this gives c dash equals 0, or s equals half into root of gamma by m into t square. That shows displacement s, or the distance covered by the particle, is proportional to t square, hence the statement C is false. Let us now examine statement D. A force is said to be conservative if the work done by the force is converted entirely into recoverable energy like potential energy or kinetic energy, else it is not conservative. Let us now find out the work done by the force during any time t. W equals F into S equals root of m gamma into half into root of gamma divided by m into t square, or W equals half into gamma t square. Also given dk divided by dt equals gamma t, or dk equals gamma t dt, Integrating both sides, we get kinetic energy K equals half gamma T square plus C double dash. Since at T equals 0, kinetic energy is 0, so we get C double dash equals 0 or kinetic energy K equals half gamma T square. We can see for sure that work done by the force, W equals the increase in kinetic energy K, and hence the force F is conservative in nature. Hence, statement D is also correct. In nutshell, the statements A, B and D are correct and statement C is not correct. Our next question is, consider a thin square plate floating on a viscous liquid in a large tank. The height h of the liquid in the tank is much less than the width of the tank. The floating plate is pulled horizontally with a constant velocity u0. Which of the following statements is or are true? Statement A, the resistive force of the liquid on the plate is inversely proportional to H. Statement B, the resistive force of the liquid on the plate is independent of the area of the plate. Statement C, the tangential stress on the floor of the tank increases with U0. And statement D, the tangential stress on the plate varies linearly with viscosity eta of the liquid. This is a very simple question from viscosity and hence from the mechanical properties of the fluids and may have one or more than one statements correct. Let us now try to understand this question. The forces acting on the plate and on the floor of the tank are shown in the figure, where Fv is the viscous force and F is the force applied on the plate. The viscous force acting on the plate is given by Fv equals eta into A into dV divided by dz. Since the height h of the liquid in the tank is very small, we may write dV divided by dz equals u0 divided by h, and hence the force Fv becomes Fv equals eta into A into u0 divided by h. It is therefore clear that the viscous force acting on the plate is inversely proportional to h, and hence statement A is true. The viscous force Fv acting on the plate is directly proportional to area of the plate, and hence statement B is false. Since the tangential force acting on the floor of the tank is equal to the viscous force acting on the plate, therefore the tangential stress acting on the floor of the tank is directly proportional to u0, and hence statement C is also true. Furthermore, the tangential stress acting on the floor is directly proportional to the coefficient of viscosity eta, and hence statement D is also correct. To summarize, statements A, C and D are true and statement B is false. Our next question from this series is, an infinitely long, thin, non-conducting wire is parallel to the z-axis and carries a uniform line charge density lambda. It pierces a thin, non-conducting spherical shell of radius capital R in such a way that the arc PQ subtends an angle of 120 degree at the center O of the spherical shell as shown in the figure. The permittivity of the free space is epsilon naught. Which of the statements is or are true? Statement A, the electric flux through the shell is root 3 R into lambda divided by epsilon naught. Statement B, the Z component of the electric field is 0 at all points on the surface of the shell. Statement C. The electric flux through the shell is root 2 r into lambda divided by epsilon naught. And statement D. The electric field is normal to the surface of the shell at all points. It is an interesting problem based on Gauss theorem in electrostatics and may have one or more than one statements correct. Let us try to analyze the statements one by one. Statement A. As per the Gauss theorem, the electric flux emerging out from a closed surface is equal to 1 by epsilon naught times the charge enclosed in the closed surface. That is, integral of E dot of ds over a closed surface S equals Q enclosed divided by epsilon naught. As can be seen from the figure that the length of the line segment PQ equals twice of r into sine of 60 degrees, which equals twice of r into root 3 divided by 2, which equals root 3 times of r. Hence, the charge enclosed, that is Q enclosed, equals root 3 r into lambda. And hence, the electric flux through the spherical shell equals phi equals root 3 r into lambda divided by epsilon naught. And hence, statement A is true. Now, the statement B. For a uniformly charged long straight line, the electric field is always perpendicular to the line. Since the line is parallel to the z-axis, the component of the electric field parallel to the z-axis is 0 everywhere, and hence statement B is also true. Statement C. As calculated in statement A, the flux phi equals root 3 into r lambda divided by epsilon naught. Therefore, phi equals root 2 r lambda divided by epsilon naught cannot be true, and hence statement C is false. Finally, the statement D. In case the spherical shell would have been conducting, the electric field emerging out from the conducting shell would have been normal to the surface. However, in the given problem, the spherical shell is non-conducting, therefore the electric field may not be normal to the surface everywhere, and hence statement D is also false. So, in this problem, statements A and B are true, whereas statements C and D are false. Our next question is, in a radioactive decay chain, 232 thorium 90 nucleus decays to 212 lead 82 nucleus. Let N alpha and N beta be the number of alpha and beta particles respectively emitted in this decay. Which of the statements is or are true? Statement A, N alpha equals 5. Statement B, N alpha equals 6. Statement C, N beta equals 2. And statement D, N beta equals 4. It is a very simple problem from nuclear physics and may have one or more than one statements true. A close examination of the problem reveals that out of statements A and B, only one may be correct. Likewise, out of statements C and D, only one statement may be correct. Let us now solve this question. Let capital A denotes the mass number and capital Z denotes the atomic number of the parent nucleus. When the nucleus undergoes an alpha decay, its mass number decreases by 4, whereas its atomic number decreases by 2. Likewise, when the parent nucleus undergoes a beta minus decay, its mass number remains unchanged, whereas its atomic number increases by 1 unit as shown. In the given decay, 232 thorium-90 decays to 212 lead-82. The mass number decreases by 20 units and the atomic number decreases by 8 units as shown. So, the number of alpha particles emitted, n alpha equals 20 divided by 4 equal to 5. If 5 alpha particles are emitted, then the expected decrease in the atomic number is 10. However, in the given problem, the decrease in atomic number is only 8. That clearly means that along with 5 alpha decays, the parent nucleus undergoes 2 beta decays. Hence, n beta equals 2. From the above discussion, it is clear that statements A and C are true, whereas statements B and D are false. Our next question is, in an experiment, to measure the speed of sound by a resonating air column, a tuning fork of frequency 500 Hz is used. The length of the air column is varied by changing the level of the water in the resonance tube. 2 successive resonances are heard at air columns of length 50.7 centimeters and 83.9 centimeters. Which of the following statements is or are true? Statement A. The speed of sound determined from this experiment is 332 meters per second. Statement B. The end correction in this experiment is 0.9 centimeters. Statement C. The wavelength of the sound wave is 66.4 centimeters. And statement D. The resonance at 50.7 centimeters corresponds to the fundamental harmonic. This is a nice problem from sound and waves and hence form mechanical waves and may have one or more than one statements correct. Let us now try to solve this question. This is a problem based on an air column that is closed at one end and open at the other end and is known as the closed pipe. In any case, the distance between 2 successive resonances is given by is lambda by 2, where lambda is the wavelength of the wave used, or lambda by 2 equals 83.9 minus 50.7 centimeters, which equals 33.2 centimeters, and hence the wavelength lambda equals twice into 33.2 equals 66.4 centimeters. This answer matches with statement C and hence statement C is true. We know that the speed of sound, C equals frequency multiplied by wavelength. Therefore, speed of sound C equals 500 multiplied by 66.4 centimeters, which gives me C equals 332 meters per second. This matches with statement A and hence statement A is also true. In this given problem, out of the 2 resonances, the resonance with shorter air column has a length of 50.7 centimeters, which is greater than half the wavelength, that is 33.2 centimeters. And hence, the previous resonance will occur at a length of L equals 50.7 minus 33.2 equals 17.5 5 centimeters. Since the resonance at 50.7 centimeters is not the first resonance, therefore it does not correspond to the fundamental mode of vibration, and hence statement D is false. In a closed pipe, the first resonance should occur at a length of lambda by 4, which in this case is 66.4 divided by 4 equals 16.6 centimeters. However, the experimental observation shows that the resonance takes place at 17.5 centimeters. Hence, the end correction is 16.6 minus 17.5 centimeters, which equals minus of 0.9 centimeters. Neglecting the negative sign, we get the end correction is 0.9 centimeters, which matches with statement B, and hence statement B is also correct. To summarize, it is clear that statements A, B and C are true, whereas statement D is false. Our last question of section A, that means the multiple choice questions, is: a wire is bent in the shape of a right angle triangle and is placed in front of a concave mirror of focal length small f as shown in the figure. Which of the figures shown in the four options qualitatively represent the shape of the image of the bent wire? Bracket starts. These figures are not to the scale. Bracket closed. The options are given as four diagrams. It is a question based on reflection of light from spherical mirrors and hence from ray optics, and may have one or more of the four figures qualitatively represent the image of the wire. Let us now try to solve this question. Let triangle ABC represents the bent wire acting as the object for the concave mirror, and let PQR represents image of the wire ABC in the concave mirror. Let us first of all find out the location of point P, the image of the point A in the concave mirror. We have UA equals minus of f by 2, VA equals question mark. Using the mirror formula 1 by V plus 1 by U equals 1 by F, we get 1 by VA plus 1 divided by minus of F by 2 equals 1 divided by minus F, or 1 by VA equals 2 by F minus 1 by F, which equals 1 by F, or VA equals F. This clearly means that the point P, the image of point A, will be at a distance of F behind the concave mirror, and the transverse magnification of the image of the line AB, MAB, equals minus V divided by U, which equals minus of F divided by minus of F divided by 2, or MAB equals 2. That clearly means that the image of the line segment AB will be erect and has a height which is twice as great as the size of AB. Let us now try to find out the location of point R, the image of point C. We have UC equals minus F and VC equals question mark. Using the mirror formula, we get 1 divided by VC plus 1 divided by minus of F equals 1 divided by minus of F, or 1 by VC equals 0, which implies Vc equals infinity. That clearly means that the point R will be at infinite distance away from the mirror, and hence options A and C are false. Principally, the image of line segment BC must meet the image of the line segment AC at infinity. However, in the figure B, the image of the line segment BC is diverging away from the image of the line segment AC. Hence, that cannot be the right answer. So, the only answer that may be true is option D. So, therefore, option D is the right answer. Students, I hope you enjoyed this innovative and visualization based problem. With this problem, we have come to an end of the 6 problems of section 1 from JEE Advanced 2018 paper 2 physics. To summarize, out of the 6 problems, only question 1 was relatively difficult and the other 5 questions were fairly simple. And therefore don't get panic. If you work little harder and try to understand the problems with your own brain, things are not very difficult and your success is guaranteed. In case you have any difficulties, please write to me and I will answer all your questions. Don't forget to comment, like, share and subscribe this channel, and do visit us again for our next video. Till then, smile and be successful.